Good morning, all of you. Today we are going to the next chapter, that is solution, binary solution. Binary solution means two component system. In that, one solute is there, one solvent also. Only two components are present. That's why we say binary solution. B-I-N-A-R-Y. Binary solution. Normally we mix common salt with water to make salt solution. So here salt is the solute. Salt is the solute and water is the solvent. So this is a common example for binary solution. Here salt is a solute. I told you that solute is a solid and water is the liquid. So solid in liquid. This is the most common example. Solid in liquid. But solid can be dissolved in solid. Solid can be dissolved in gas. Similarly, liquid can be dissolved in solid. Liquid can be dissolved in liquid. Liquid can be dissolved in gas. Again, gas can be dissolved in solid, liquid, gas. So we'll be getting 9 types of solutions. Solid in solid, solid in liquid, solid in gas. So 3 types of solution. Now again, liquid in solid, liquid in liquid, liquid in gas. And again, gas in solid, gas in liquid, gas in gas. So there are 9 types of solutions. And in junior classes, you learned heterogeneous and homogeneous words. Gas in gas is always homogeneous. In junior classes, you learn one more term, colloids. Colloids are heterogeneous. Colloids can be classified in this matter, solid in solid, solid in liquid, etc. But in colloids, there are only 8 types because the last one, gas in gas, since it is homogeneous, it is not a colloid. In this chapter, we will not discuss about the colloids. Here we have 9 types of solutions. Solid in solid. Example, solid in solid, that is ornamental gold, alloy. Alloys are the examples for solid in solid. You know that pure gold is 24 karat. But if you make the ornaments with this, if you make these ornaments with 24 karat gold, the ornament becomes very brittle. So we add what copper in that gold, and it is made to 22 karat. The ornaments made up of this 22 karat gold is not brittle; it is long lasting. And the addition of copper gives a bright luster to the ornament. So, due to these reasons, copper is added into gold, and 22 karat gold is used to make ornaments. So, solid in solid, copper in gold is an example for solid in solid solution. Then, solid in liquid, normal common salt dissolved in water is the example. Solid in gas, camphor in nitrogen. You know that camphor on heating, it sublimes. So camphor atoms will be moving into the air. It can be mixed with any gas, camphor in nitrogen, camphor in air. So camphor in nitrogen is a typical example for solid in gas. Next, liquid. Liquid in solid. Sodium amalgam. Amalgam means mercury. Hg, mercury is a liquid. So sodium amalgam is an example, Hg slash Na. Hg slash Na. We write sodium amalgam like that. So sodium amalgam is an example for this liquid in solid. Then liquid in liquid. Alcohol in water. Alcohol is a liquid. Alcohol can be mixed with water in any proportion. Less alcohol, more alcohol, less water, equal amount of alcohol and water. Alcohol can be Alcohol is miscible with water in any proportion. So this is a typical example for liquid in liquid. Then liquid in gas. Liquid in gas, chloroform in nitrogen gas. Chloroform in nitrogen gas. Chloroform is a liquid. You know that in olden times, chloroform, in movies you must have seen, chloroform is taken in a hanky or this kerchief and it is shown here to make the people fainted. So chloroform in nitrogen, that is liquid in gas. Next, gas in solid. Gas in solid. H2PD, H2PT, yeah, H2Ni. This H2PD, it's a catalyst, you know. In class 10th, you learned H2PD is used for the catalytic hydrogenation to make vanaspati ghee from vegetable oil. So H2PD, that is H2 gas, PD solid. So H2PD or H2Ni or H2PT, these catalysts, this is an example for the solution. What solution? Gas in solid. Now gas in liquid. Common example, that is oxygen dissolved in water. You know that fishes can survive by breathing the dissolved oxygen in water. If that fish is taken outside this water, then it will die. The outside oxygen it cannot breathe. Fishes can breathe only the dissolved oxygen. So oxygen in water, oxygen already got dissolved in water. During summer season, the dissolved oxygen go up. So what happens? The surface water will be having less amount of oxygen. So fish feels uncomfortable in the surface water. So it dives down, it goes down to breathe the dissolved oxygen. So gas in liquid. Example, oxygen gas dissolved in water. Then gas in gas. Gas in gas. Here, the example again, oxygen mixed with nitrogen or air, gas in gas, oxygen mixed with nitrogen. So these are the examples for these 9 binary solution. Now in this chapter, solution, we are going to see the concentrations of the solution. How to express the concentration. First, we will be learning the concentration of the solution, how to express this concentration, whether it is a dilute solution or concentrated solution, etc. What is the percentage composition of that solution? In what all ways the concentration of the solution can be expressed? Such things we'll be learning in this chapter. Let's go to concentrations of the solution. Whether it is a dilute solution or highly concentrated solution, you can use the term concentration of the solution. Expressing concentration of a solution. First one, percentage composition. Percentage composition. Mass percent. Mass percent. That is W by W. You can show it as W slash W. That is mass of the solute upon total mass of the solution into 100. So the first W stands for, this W stands for mass of the solute. This W stands for mass of the solution, not the mass of the solvent. So W slash W means both you are talking in terms of mass. In chemistry, mass and weight are taken in the same meaning. Number 2, volume percent. V slash V. That is volume of the solute upon total volume of the solution into 100. Number 3, mass by volume. Mass by volume percent. That is W slash V. In medicines, that is in suspension, liquid medicines, it is given in this format. That is W, mass of the solute, mass of that medicine, maybe paracetamol or nimulid, in total volume of the solution. You must have seen a bottle of 100 ml cough syrups. Cough syrups, a bottle of 100 ml, in that the medicine is there, a particular weight of the medicine, and the total volume of the solution. This is 100 ml cough syrup or 100 ml nimulid suspension, like that. Next way of expressing is parts per million. If the solute amount is in minute quantities, we say parts per million. Then mole fraction. Mole fraction. Last year we learned mole fraction. Then molarity. Molarity. Number 5, molality. Molarity and molality. These two terms we have learned. We have already learned in class 11th. Mass percentage, mass percentage also we have learned. ppm little bit we have learned. We'll be revising these things right now. So first one is mass percent. Mass percent. How to find out the mass percent? Mass percent, that is W slash W, is equal to mass of one component. Mass of the component divided by total mass of the solution. Total mass of the solution into 100. Mass of the component upon total mass of the solution into 100. That means we are finding out the amount of the solution in 100 gram of solution. So whenever you see percentage, you have to consider 100 gram of the solution. Consider 100 gram of the solution. Whenever you see this sign percentage, you have to consider 100 gram of the solution. In that 100 gram of the solution, what is the in that 100 gram of the solution, what is the amount of the in the 100 gram of solution, what is the amount of the solute that we are telling? So we get the amount of the solute. For example, 40% solution means 40 gram of the solute, 40 gram of the solute and 60 gram of the solvent. 40 gram of the solute and 60 gram of the solvent. Now, for us, this 40 gram, that is not a useful term for us. We will be finding out the number of moles present in 40 gram. For example, if the solute is NaOH, then what we will do? We can find out the number of moles for some other calculation. So what is the mass percentage? Such a question will not be asked for you. Such a question is asked for class 11th. What is the mass percentage? That is irrelevant for us. But we have to find out the molarity. We have to find out the number of moles in this 40 gram. If it is NaOH, how can we find out the number of moles? Number of moles 40 upon molar mass of that NaOH. Molar mass of this NaOH, that is 23.16 plus 1, that is 40. So we'll be dividing it by that 40. That means 1 mole. So mass percentage term is a side part of a question. Directly, they may not ask mass percentage. Sometimes, for 1 mark question or 2 mark question, they can ask. Alright, so we are coming to mass percentage, that is a mass of the component upon total mass of the solution into 100. Next is volume percent. Volume percent, that is V/V. That is volume of the component upon total volume of the solution into 100. Volume percent. This is not of much use for us. For us, mainly mass percent. So volume of the component upon total volume of the solution into 100. Now mass by volume percent. Mass by volume percent. That is W/V is equal to mass of the component upon total volume of the solution. Total volume of the solution into 100. It is used in medicine, syrups, used in this mass by volume percent is used in syrups. I told you cough syrup or medicinal use. Next, we are going to see ppm, parts per million. Parts per million. When solute is present in trace quantities or minute quantities, this ppm is used. Concentration of pollutants in air is often expressed in ppm. Concentration of this impurities, the concentration of the pollutants in air is expressed in ppm, parts per million. Means in 1 million, how much is present? In 1 million gram of the air, how much gram of this pollutant is present? 1 million means 10 to the power minus 6, sorry, 10 to the power 6, that is 10 to the power 6, that is 1 million. So parts per million, we are showing number of parts of one component. Number of means how many parts are present. Number of parts of one component. One component divided by total parts of all components. Total parts of all components into 10 to the power 6. You may be getting the value in 100 grams, 100 gram total parts 100 grams, but you are calculating it for, you are finding it for 10 to the power 6 grams of the solution. So total parts of all components, suppose they are telling that 5 gram is present in total 100 gram. But we are not telling in 100 gram, we are telling in 10 to the power 6 gram of the solution. 5 gram in 100 gram, 5 gram of solute in 100 gram is a big quantity. But if the quantity is 0.0015 gram in 100 gram of solution, see it is a minute quantity. In 100 gram of the solution, or if 100 gram of the air, 0.0015 gram of the pollutant is present or chloroform is present. So nobody cares about that. So we are telling in 10 to the power 6 gram of the air how much pollutant is present. Then this number will be a bigger number in 10 to the power 6. So 10 to the power 2 or in 100 gram of solution, how much gram I said? 0.0015 gram of the pollutant is present. Pollutant. But this value, this much is present means nobody cares about that pollutant. But if I say the same value in 10 to the power 6, that is in 10 to the power 6, how much pollutant is present? 0.0015 upon 100 into 10 to the power 6. So this is 10 to the power 4. 10 to the power 4 means 15 gram. When we hear this term 15 gram, then we are serious about the pollutant. Then we are serious about the pollutant. So 100 gram, they may be given in percentage. They may be given in percentage. That is 0.0015 gram of the pollutant is present in 100 grams. That means this much is the percentage. This much is the percentage. That is 15 into 10 to the power minus 4. This is 15 into 10 to the power minus 4. So percentage will be given to you and you have to find out the ppm. What is ppm? 15 ppm. This is 15 ppm. Next term is mole fraction. Mole fraction. Fraction. Fraction is always a quantity we express less than 1. Suppose two components are there. Fraction of one component may be 0.4. Then the fraction of the other component will be 0.6. The sum total of all the fractions will be equal to 1. Here we are finding out mole fraction. Fraction in terms of moles. Suppose two components A and B are present. Mole fraction of A is known as XA and mole fraction of B is taken as XB. XA is equal to Na upon total, that is Na plus Nb. That is the mole fraction. Fraction in terms of moles. And XB, that is Nb upon Na plus Nb. Now this what is Na? Na is equal to Wa upon its molar mass Ma. And what is Nb? Nb is Wb, weight of B, upon Mb, molar mass. So to find out the number of moles, the given weight, the given mass upon molar mass, given mass upon molar mass, that is Na or Nb, given mass upon molar mass. So first you have to find out this Na and Nb. First you have to find out the number of moles of each component. Mass will be given, any mass will be given. Here also any mass will be given. So first you have to find out the number of moles of A and number of moles of B. Then Na upon Na plus Nb will give you Xa, and Nb upon Na plus Nb will give you Xb. See, we have found out the mole fraction, and this value will be, this Xa will be a quantity less than 1 because it is fraction, Xb a quantity less than 1, and when you add these two, then you will be getting 1. So mole fraction of all the components in a solution is unity. Mole fraction of all the components in a solution is unity. Suppose there are three components. Then XC, three components. Then here it will be NC. Here also it will be NC. And X is equal to NC upon Na plus Nb plus Nc. Now you add all those things. Xa plus Xb plus Xc is equal to 1. If there are I components, that is Xa plus Xb plus Xc plus etc. Xi is equal to 1. So the sum of the mole fractions of all the components in a solution is unity. Question. Calculate the mole fraction of benzene in a solution containing 30% by mass. 30% by mass means 30 gram of the solution, 30 gram of the solute in 100 gram of the solution. 30 gram solute. 30 gram solute in 100 gram solution. So what is the mass of the solvent? 70 gram. 70 gram of the mass of the 70 gram is the mass of the solvent, right? This is what is meant by 30% by mass. You have to consider 100 gram solution. So I'm writing in bracket. Consider means it's percentage. Seeing the percentage, I told you, consider 100 gram solution. Okay, consider this by mass in carbon tetrachloride. Carbon tetrachloride. Carbon tetrachloride, that is CCl4. CCl4. So you have to find out the mole fraction. Mole fraction of benzene, that is XB. B is always considered as the solute. B is considered as the solute and A is considered as the solvent generally. Now we have to find out the mole fraction of the solute, that is XB, that is B4, that solute is benzene. So XB is equal to, that is NB upon Na plus NB. We need this mole fraction term because after 2 days or in the coming days we'll be learning a Raoult's law. So there we need mole fraction. That's why I'm teaching mole fraction now. What is mole fraction? When we learn Raoult's law, Henry's law, we need the mole fractions. So this is a preparatory step for that Henry's law and Raoult's law, what we are going to learn in the coming classes. So XB is equal to NB upon Na plus NB. What is NB? NB is WB upon MB whole divided by WA upon MA plus WB upon MB, which is equal to WB, that is mass of the solute. What is the mass of the solute? See, we have a solution of 100 gram. We have a solution of 100 gram. In that 30 gram is solute and 70 gram is solvent. What is the solvent here? CCl4. So 30 divided by its molar mass. What is the molar mass of benzene? Molar mass of benzene. Molar mass of benzene, that is C6H6. C6H6 means 78. 78. 6 into 12 plus 6. So 78. So I am writing 78 here. 78 divided by mass of the solvent. What is the mass of the solvent? 70. Mass of the solvent is 70 upon its molar mass. What is its molar mass? For molar mass, you have to calculate CCl4. This is CCl4. That means 12 plus 35.5 into 4. So altogether 154. 154. So I am dividing this 70 by 154. Then plus again 30 upon 78. So after calculation you will be getting that fraction, mole fraction, that is always less than 1. So after calculation you will be getting the answer as 0.458. See, this value is less than 1. So this is the mole fraction of the solute. Then what will be the mole fraction of the solvent? 1 minus this value. So mole fraction of carbon tetrachloride, that is not asked in the question. If it is asked, then what you have to do? 1 minus this, because only two components are there. Benzene's mole fraction is 0.458. So what will be the mole fraction of carbon tetrachloride? Benzene is soluble in carbon tetrachloride. Benzene is insoluble in water. Benzene is organic. It's non-polar solute. Non-polar solutes are soluble in non-polar solvents. Polar solutes are soluble in polar solvent. Non-polar solutes are soluble in non-polar solvents. Generally, means like dissolves like. Polar solutes are soluble in polar solvents. Non-polar solutes are soluble in non-polar solvents. So this benzene is non-polar. CCl4 is also non-polar. So benzene is soluble in carbon tetrachloride, CCl4, like dissolves like. Okay, that's about mole fraction. Next, we'll see next term, that is molarity. Molarity. It is the number of moles of solute. Moles of solute. How many moles of solute? Moles of solute upon volume of solution in liter. Volume of solution in liters. In liters. Volume of solution in liters. So first you have to find out the moles of the solute. Moles of the solute. In the previous numerical, what is the moles of the solute? That is 30 upon 78, right? Moles of solute. Now volume of solution in liters. Solution volume, it is not given, but solution weight is given, that is 100 gram. So first you convert this 100 grams into volume. So you know that mass by density is volume. So if they provide the density of the solution, you can find out the volume, and that volume you have to put in liters. That volume you have to put in liters. So here in the previous question, they haven't given the density. If they give the density, then how will we write? That 100 grams upon its density. If they give the density, you can write like this. And this much is ml. 100 gram density, if they give in grams per centimeter cube or grams per ml, then you are getting this grams will get cancelled, this ml will go there, so you will be getting that ml. So what you are getting here in ml, in ml, this ml, what you have to do, you have to divide it by 1000, then you will get it is in liters. So you will be getting in liters. So here now will we write liters. So molarity is the moles of solute upon volume of the solution in liters. Let's see the question. Number 1. Calculate the molarity. Calculate the molarity of a solution containing 5 gram NaOH in 450 ml solution. So molarity is represented by capital M, that is 5 gram. What is the number of moles? NaOH it is. So 40 divided by, here ml is directly given, so 450 upon 100, which is equal to the molarity, that is 0.125 upon 450 into 100. So this much, what we write, the answer, this much molar, the unit will be capital M. Unit will be capital M. Now next is molality. Molality. Molality is again, numerator is the same, moles of solute. moles of solute upon mass of solvent in kg. Here you have to separate that mass of solvent. Mass of solvent. If it is given in grams, you have to you have to convert in kg. Moles of solute upon mass of solvent in kg. In the case of molarity, it was volume of solution in liters. Here it is mass of solvent in kg. Mass of solvent in kg. This molality also we require for further topics in this chapter. So I am stopping here. So two terms are very much important: molarity and molality. Molarity, last year you learned molarity, last year you learned molality also. Molarity is the number of moles of solute upon volume of solution in liters. That is molarity. What is molality? L. 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 Molality. This L. That is moles of solute, number of moles of solute upon mass of solvent in kg. Thank you.